All right, we're going to get started in just a minute here, waiting for a few others to join. All right. Right, so this webinar is covering Python for civil engineers, and just kind of giving some background about Python, about the civil engineering world and how Python relates to it, and then goes into detail about the course that Inly offers on this very topic, Python for civil engineers. So here's what we're going to cover. Like first, the market for civil engineers. Then, if you are a civil engineer, what is it taking right now to stand out professionally? Then next, how Python kind of factors into that and why Python is a big deal in general. Then what is happening in Python for civil engineers? So connecting the dots here from 1 to 3 in number 4. And then what to expect from our course and how to follow through if you take our course on Python for civil engineers. So first, the market for civil engineers. I'm covering just the US market here. So if you're joining from another country, I'm sorry, I didn't do good research into how civil engineering works elsewhere. But I think a lot of these trends might apply beyond just the US. So what you'll notice here is this was published in 2019 by the Bureau of Labor Statistics here in the US. And you see the job outlook from 2019 through the next 10 years there. So 11 years total span is 2%, which is slower than average. I think engineers on average, it's about 4% projected growth, skewed more towards computer engineering and data science, software engineering, that kind of thing. So it's kind of on the lower edge of the growth there. But what's redeeming about it is that it's one of the top jobs in terms of job security. So if you get hired as a civil engineer, it's very unlikely that you'll then be let go. Um, and that job security is worth enough to many civil engineers to help overcome the concept that their annual wage is perhaps smaller than average. So the other thing to notice here is this projected job growth is from 2016 to 2026, and that was 11%. So you'll notice there's a big slowdown in job growth for civil engineers as projected here. This is USA Today, this is Bureau of Labor Statistics. So two different sources and unclear exactly how they're doing that research. But so it's becoming more competitive to get one of these coveted, highly secure jobs in the civil engineering world. Right. So, so what might happen next? Here we see the percent change in employment projected from 2019 to 2029. This again is from the Bureau of Labor Statistics, and it's showing, total engineers and all occupations in engineering growth rate of 4%, whereas for civil engineers, it's 2%. And this is my paraphrasing the text that they have on that site. So the Bureau of Labor Statistics is a US government site. And they have some advice listed in there. First, they say, learn to diversify the application of your skills. They go on to talk about how you shouldn't expect as much from heavy industry in the world of civil engineering, but infrastructure needs help. But then when they talk about infrastructure, they say, there's less budget for that kind of work. And what I know from civil engineers um, in my network of people I've worked with in the past is that the trend is towards outsourcing a lot of the design work to offshore. So offshore civil engineers are doing that work because it's cheaper for the engineering company or the EPC that typically employs the civil engineers to scale down how many employees they have and then rely on outsourced engineering work from people overseas. So locals, meaning people in the US, will need to check the work of others rather than be individual contributors quite as much. And they'll also need to learn to contribute higher value in less time. So in order to keep your job and stay relevant, you have to do more in less time. I'll share this presentation with people afterwards. So if you're trying to like type in this link and follow it here because you can't click on it from my shared video, um, that's totally fine. Oops, realizing that, wait a second. Oh, okay, yeah. All right, let's keep going. So next part here, we talked about the market for civil engineers. Let's talk about how to stand out professionally. And by the way, if you have questions as we go, you can post them in the chat. So feel free to do that. Here, I'm just gonna pull it open. Feel free to type questions here. So how to stand out professionally. What I'm noticing the current winners are doing, and I see this in the consulting work that I do, and I see this in the clients that I have from the software company that I run. People who are efficient are getting ahead. So I just kind of gave some context for civil engineers based on what it shows in the Bureau of Labor Statistics here. But if you can automate repetitive tasks, that's a big deal for efficiency. So rather than say do the same task every week that takes you 2 or 3 hours each time to build from scratch, you can instead do it once and then have it automated from then on. Next, if you can reduce human error, that's a big deal. So if you do some sort of civil engineering work and then you find a mistake in it and then you have to redo it, that's pretty costly in terms of efficiency. So whatever you can do to reduce that human error is a good thing. And then, third is if you have an eye towards like combining and eliminating workflows. So maybe one team works on something and somebody else works on something and you realize that part of that work effort is like overlapped, then, maybe only one of those teams needs to do that part and the other team can just add their efforts on top of it. So looking for ways to like create that sort of synergy inside of the civil engineering world is important to driving that efficiency. Next up, being data driven. So this means as an organization or as a team, you're capturing the right data. So being data driven, you got to capture the right data. Then you have to make that data accessible. So the data is available for you and your team so that you can actually work with it. And third, you want to be able to use modern data science methods to evaluate that data. So getting the right data captured, that involves like sensors, or that involves the right kind of organization of data that you're already capturing in other ways. Making it accessible means that it's shared someplace, typically online, where others can go to find it and make sure that it's working for you. And then the use of modern data science methods, I'm talking about mostly machine learning methods that have become popular because of their utility recently. So in terms of versatility, this is the third factor. First, you should be thinking like, what else is going on out there? Like how else are civil engineers adding value? And if you stay plugged into that, then you can kind of like find ways to add additional value within your firm or the context of your work if you're, say, like a consultant. So you can suggest more things to add value to your clients or to your boss or to a team down the hall. So when you discover what else is going on, then the next question is, how can you learn about it so you can start contributing in that way? And third, then how can you add value in those places? So this is kind of a iterative process. You're always thinking about what's going on. If there's some value you think that could be added somewhere, how can you learn about it? And then actually executing on that, finding time at the end of the workday or in the weekends to learn more stuff so that you can continue to upskill yourself. So, all right, a lot of talk there about how to stand out professionally. Next up, why Python is a big deal. So how does Python kind of fit into this stuff? So first, what does Python really do? If you look at the 2020 Python official documentation, just by going to the Python website and reading what they have there, the definition that Python gives to itself is it's a high-level general purpose programming language that can be applied to many different classes of problems. So what is meant by that high level versus low level programming language? It's great to hear that it can be applied to many classes of problems, but what's high level? And if it's high level, is there some sort of trade-off there? So, stepping back from Python, let's review what the difference is between low level and high level generally. So low level languages are languages where normally you have to tell the machine, your computer or whatever else you're working for, there's a computer involved, but sometimes low level languages have something to do with heavy equipment or sensors or something like that. So you're telling the equipment in question how specifically to handle each of your instructions. So instead of just writing in some code and saying, do this for me, you write in code and you say, do this for me in this way, and I want you to use this area on the computer to store the memory temporarily. And I want to use this operating system to execute this part, and maybe use this other thing to execute this other part. So that's kind of how low level works. It's typically much harder to code, but it's much more optimized because it lets the human get really specific about how things are done. And it has a major dependency on outside structures and services. So if you change one thing about how your computer is built, maybe some of those methods that you had hard coded and specified in your script are broken because they're no longer possible. And then it lacks the flexibility to kind of like fix that for you. So second is high level. So on the other end of the spectrum, we have high level. And if you give the machine the high level overview of what you want it to do, and then leave like how it's done up to the machine, that's where high level gets its name. So you're kind of just typing the code and saying, here's what I want done. And then you leave it alone and the machine will try to figure out for you what's going on there. So that's high level versus low level. The code has very little dependency on outside structures and services in high level, which means if you change something, it still works. Okay, so it seems like high level is just sort of strictly better, but that's not necessarily true. There's some upsides to low level. One is it's quicker for machines to execute when everything is set up properly. Second is there's less what you call overhead when you're interpreting human generated code. So rather than the machine having to figure out like, okay, if I were to do this task in this certain way, how hard would that be? Would it work well or wouldn't it? Next, if you want to do something on the machine level, like maybe sound a buzzer or vary an engine speed or something like that, low level is better because it can communicate with things that are less complex than the average like processor on a computer, and more simple, like say, the little machine computer that determines like an actuator arm or, an engine speed. And storage is smaller because that has to do with that overhead thing as well. When you process, there's less possibilities for how it could connect to get things done for you. High level, the advantages are it's much easier for people to learn. So if you want to learn how to script some software and you learn a high level language, that's a big help. It's also easier for humans to find and troubleshoot what problems arose. You're more likely to do something on a human interaction level in high level, like render a web page or interpret user input, so something that involves people, typically done on a high level, including, if people are working together to get some kind of project done, even if it's a technical project. And the associated files, while bigger, are more versatile. So we talked about that. If you were to switch to a different build or a different system, different architecture, chances are you could still reuse your code if you coded it in high level. So Python, like it says in the official documentation, is over here. It's a high level language. But low level, Python, even though it's high level, covers some of these bases in the low level area as well. And that's the whole point of this page, is to explain that Python is kind of a special high-level language in its capabilities here to touch base on these like low-level advantages. So, there are other low-level languages that perhaps are better at these things than Python, but Python is still really fast, for example. So, good for Python. Maybe like you've built something in Fortran before and it just executes super fast. Or if you want to do like, 100 million iterations of the same little code, Fortran is faster than Python in that case. But, that scenario is perhaps not very likely. And even if you were to use Python instead of Fortran in that scenario, the additional benefit of Fortran wouldn't be that big as compared to Python. We talk about less overhead. Actually, Python is written in such a way that it's really good at optimizing execution. To me, this seems downright magical, like it'll just sort of figure out, oh, this is the best way to do this without you having to explain anything, as opposed to a lot of high-level languages that figure out, okay, this is one way of doing something. Next up, Python is still really good at interacting with machines. So there's a lot of Python libraries and packages out there that help Python, interpret information from sensors or send signals out that those sensors can then interpret from the Python code. It's also like really kind of nice and tidy. So when you create files in Python, it tends to be like not taking up too much space on your computer. So, hey, Python as a software language is doing pretty well here, and that helps to explain why it's so popular. So a little bit about that popularity. If you look at how many people are using Python, there's a couple ways to kind of measure that. Like, I don't think that there's a single list out there that somebody has deduced that, interprets somehow exactly how many people are using it. So instead we look at proxies. So if we look at how many projects are open sourced and published for the general Python user community, we see that when I created this slide, I think I took this screenshot a couple months ago from pypy.org here, that there were like 250,000 projects, but more than 2 million releases, and 3.2, 3.3 and a quarter million files, and then tons and tons of users. So, and users are sometimes organizations. So this is not a direct representation of people here. So quite a large number of projects. These are all different codes that might be useful to you, or libraries that might be useful depending on what niche in Python you want to apply to, including civil engineering. So Python on its official documentation says there are probably millions of users, so it's difficult to obtain an exact count. Well, that's a pretty modest statement, as we'll see in the next couple slides. Because it's free, that helps a lot. But that all, helps to generate popularity, but there aren't any sales figures, so they're not like Python is not tracking this itself, right? So here's a great proxy. There's this website called Stack Overflow, and Stack Overflow is where people go when they have questions about how best to get code done. So, hey, I'm trying to code this thing, but I'm running into an error. Can anyone advise me? So it's kind of like a forum. So if you go to Stack Overflow and ask a question, if you ask a question about Python, Stack Overflow will track that as compared to asking a question about some other languages. And you can see here, this is the growth rate of questions asked about Python. So the volume of information about Python and how to get stuff done on that community of that forum has grown pretty quickly. It's greater than linear here from 2012 to 2018. I can't wait to see what they come out with next year. I think it'll continue. The slope will continue to increase there. Another interesting thing. So this is a chart that shows the percent of 2017. So a couple 3 years ago, traffic going to Python in Stack Overflow versus 2016 traffic going to Python. So just comparison of those 2 years. So anything above this line shows an improvement over the previous year. And then the size of the dot, when we're looking at across all of these different areas, when people are asking kinds of questions, hey, I'm trying to do something in the academic world and I need help, versus, hey, I'm trying to do something in government or electronics. The size of the dot there shows the spread in application interest in Python. So we see, tech, of course, is big, finance is big, energy is a tiny dot there, And there's, I would say probably manufacturing is where civil engineering might fit, just given what I see here. The way that they break these down is perhaps not ideal to us, but this is mostly just to show that there continues to be growth in Python in all of these. So there isn't a single one that's down below here. So really growing across all industries. Another great thing about Python is that it's really useful in the world of data science. So it's kind of become the de facto tool for data science. Back in, 5, 6 years ago, um, we see Python was kind of in second place, and R, which has since become kind of more academic and less used in the actual industry, was number one. And then we had SQL down here, and SQL is a data query language, not necessarily a data science language, but it was definitely a useful tool from data scientists. RapidMiner, Hadoop, Spark, we see these other things. Scikit-learn is actually a Python implementation, so maybe this credit needs to get added to this one. But when we get up to 2017 through 2019, Python becomes the clear winner here. And we've noticed R has dropped in popularity. I got this slide from DZone, something they had published in 2017. And then I found similar research from KD Nuggets, and that was published in 2019. So curious to see what the 2020 stats are when those things come out. But I think we'll continue to see that Python is just really undisputed as emerging as the best data science tool or most popular data science tool. All right, so let's make this relevant for civil engineers. What's happening in Python for civil engineers? You've seen this slide already. I was talking about efficiency, being data-driven, being versatile. So first, automation of repetitive tasks and reduction of human error and combining and eliminating workflows. For civil engineers, if you can learn and execute quickly, this automation part here, this is like a really big deal. Python will enable you to do that. So if you choose Python as a tool, you can learn the Python really quickly and you can execute Python really quickly to get this stuff done. So rather than having to spend like years training how to, start coding, Python lends itself very well to fast development, even if you don't have a background in computer science. So, a lot of people are saying Python has become the new Excel. And what they mean by that is that you don't have to be a computer scientist to use it. It's a general purpose tool for all kinds of people. And that's because it's really easy to learn. So if your goal is to automate stuff, you can kind of start doing that right away with Python. When it comes to reduction of human error, well, if you build a script that does something for you and your script has a problem, it's easy to debug that script in Python. Debugging means you've discovered a problem and then you spend some time trying to fix it. So a bug is a problem with whatever code was written. So debugging and testing very easily in Python, line by line of code is really useful and really easy to do. So then if you build code that does work consistently, then it's going to work the same way every time, and you cut out that possibility of human error. So not only are you, taking work that you used to have to do over and over again and automating it, so you only have to do it once, and then from then on you just press the button and it does it for you. But also, if there was some kind of tendency for you to, periodically make mistakes when you were doing the work again and again each time, that won't happen anymore because the code will do it for you. And then finally here in this efficiency part, we're talking about combining and eliminating workflows. So you can share the codes that you've made very safely inside of your organization. You don't have to worry about it crashing or somebody hacking it, or Python is open source, but it's very safe to use, and it's very clear and easy to put in your explanations of what you're doing. So, I see a lot of workflows done in Excel, and you open up Excel and it's very unclear, like which tab am I supposed to reference when, and there's a bunch of equations just kind of scattered across there with different parts of the workflow that aren't necessarily obvious unless somebody comes in and teaches it to you. Versus in Python, you get information kind of right away, and you can see what the descriptions were for each part of the code. and you know that it executes in a certain order. So that becomes really easy to kind of like understand the code that somebody else has written once you've gotten up to speed in Python without them having to sit there and tell you and look over your shoulder, right? So really good at boosting efficiency here. And that's part of why it's become so popular in the industry. Next, data-driven. So if you want to be data-driven and your goal is that you're capturing the right data, well, Python is like really good at reading all kinds of data. So you might have Word files or comma separated value files or Excel files or JSON files or whatever it is that you're dealing with. However, your data is coming in from sensors or people reporting stuff or whatever, you can kind of put it all into one workflow inside of Python, so you can like have that data interact with other data in the same formatting. And so that then leads into this data accessibility benefit here. It becomes really easy to visualize and clean data when it's all kind of interchangeable. It doesn't matter where it came from. Once it's in the same place, you can explore connections between it and then send it out where it needs to go once you've done the processing you need to do. Use of modern data science methods. Well, I call this dangerously easy. This is my own quotes here. I just saw that message from Yekta. Am I going to share the presentation file? Yeah, I have all of your emails from how you signed up in Eventbrite. So I'll send you this presentation. You'll notice that there's a ton of slides because as I go, I just add one point at a time. I'll send you like a consolidated version that just has all of the information. It's kind of meant to be like read it on your own rather than a presentation file, so it'll have all the same information in it. All right, so back to this. If you're trying to use modern data science methods, machine learning, that sort of thing, the reason why I say that's dangerously easy is that you don't even need to understand how those methods work. If you don't know how the machine learning model works and you just plug in your data, it'll treat it like a black box and give you an answer back. And that answer, it tends to be pretty good and reliable. And so then the model that you've trained can be used for some sort of regression or classification with high degree of certainty or not too much risk. But the downside of that is that if you don't understand that risk, if you don't understand the data science method that Python is allowing you to use, then you have no way of gauging what that risk is. And in some situations, it is a high amount of risk. Or maybe your model is overfit or isn't very accurate generally, but you think it is. Maybe you captured the wrong kind of data and you're using the wrong kind of machine learning method to begin with. So you kind of need to learn about that stuff on your own. And that's a separate point from talking about Python. So that's why I say it's dangerously easy. And finally, this versatility thing. So if you want to get good at this iterative process, I talked about it, like learning what else you could be doing, learning how you can then learn about that and then getting good at it so you can contribute in more ways, then Python is really good because it's use case agnostic, which means it's not like this is a scripting language just for making video games, or this is a scripting language just for communicating with sensors. It's used to make web pages, it's used to make web apps, it's used to make mobile apps. You can make all kinds of stuff using Python. Like the world of Python and the reach of what it can do continues to expand very rapidly across all kinds of industry niches and professional categories, including civil engineering. It's also really easy to build a workflow in Python and then remove your company's proprietary data from that workflow. So, hey, I built a general method here using Python to analyze stress and strain for a certain type of steel beam. And maybe the reason why somebody built that is so they could then implement that tool on their project in their job. But the tool can then be separated from the specifics of what the company is doing and be published online for others to use. And some companies don't allow that, but a lot do. And so you have all of these people who are either in teams of open source developers in the open source community, or as individual contributors, just generating all kinds of useful tools and then saving them in places where they can be discovered and tapped online. So once you kind of get your foundation of Python set, then you can go out and find all of these tools and packages and, somebody else's code, and you can just use it right when you want to inside of your workflow, and it's safe and secure to do that. It's a huge open source community, and it's free. So lots of reasons I think why Python is useful if these are your goals to try to get ahead in your career. Okay, so next up, what to expect from our course. I'm going to switch gears here. I'm no longer trying to educate about Python and share my views about civil engineering and Python. Instead, I'm going to be talking about our course in particular. So there's 4 parts to the course. The first part is we teach you how to download Python and get it set up on your computer. And that's not like, really, I don't think I really need to explain that in too much detail. Like, we've all downloaded programs and installed them because this isn't just a program that you execute directly on your computer the same way every time, but instead something that, could make queries for you for the internet to find and install new packages and that sort of thing. There's a little bit more nuance here, which is why I include it as something to learn about. Then in part 1, we cover files and storage. So how do you store different types of Python files, and how do you get Python to reference other kinds of files that you've stored elsewhere? And then how do you actually use Python? When I say how to use it, I mean like kind of on a meta level, like where does your actual code go? And where do your descriptions of your code go? And how would you then read other people's code and descriptions, that sort of thing. This is really just like the true fundamental basics here of Python. If you've had experience with other scripting languages, this will go super fast for you. If you haven't, then this will still go pretty fast for you. So nobody really gets bored, but everybody gets to understand this part pretty well. So a very small percentage of the course overall devoted to part 1. So part 2, a lot more effort devoted to this part, a lot more time in the course devoted to this part. So we learned about data types. So there are different types of data in Python. You'll notice if you have experience using Excel that if you try to like take a bunch of cells in a spreadsheet and highlight them all to see what the sum is, you'll notice on the bottom right, if all of those things are numbers or some of those things are numbers, Excel will calculate the sum of all of those numerical values for you. But if some of the things that you've put into those cells are, say, strings, which means like combinations of numbers and letters, or just letters, then those are excluded from the sum. And Excel knows how to do that because it treats those 2 different types of cells, the values in those cells, as different data types. One was numerical and one was a string. So Python has more, like there's a bunch of different data types. In fact, a lot of libraries that you download and use in Python, because it's an object-oriented programming languages, they come with their own data types. So there's really myriad data types here, and there's a lot to learn about there, how they're different, and why Python bothered to make distinctions between them. And it's pretty cool, and I think it's good, solid logic, and really can expedite things for you, make things really easy once you learn about this. And then there's the scripting commands. So if you want your computer to do something, if you want your data to move, or you want something to happen with some sort of calculation to explore your data, this is really the guts of it. You're going to be like writing commands in Python, and it's not super tough. Like the syntax is designed to be written in the same way that you would write pseudocode. So if you were going to write on a whiteboard, hey, here's what I think I need to do. First, I need to do this, then I need to do this, then I need to do this. Python is designed so that you can write to Python in kind of that same way. Then we learned about functions, which means you've written some sort of code that you want to work the same way every time. So you can tap it like a tool and say, oh, I have another use case for this function. Let me use that function and do that. Oh, I've got another use case for the same function. Let me use that function to do that one too. So these are super helpful. This is where you start to automate things here. And then there are these like library methods, which you can download, libraries for civil engineering kinds of things, and then use those methods kind of like functions. Then part 3, we talk about file importing and data cleaning. This is kind of getting into the first, level of the foundation for the data science kind of stuff. So how do you organize your data? How do you clean it to make sure that, it doesn't have errors in the data? And then how can you analyze it, and how can you graph it? So, analyzing it, you can get an answer. Graphing it, you can kind of visualize what happened to make sure that you're on the right track and get some sort of intuition about how that data was working for you. So Lots of useful stuff in here. I think that, just personally, one of the downsides of Python is that graphing is a little bit clunky still. As compared to a lot of, say, like dashboard apps, or where you just like highlight the data, show me the best way. In Python, you kind of have to tell it like a little bit more what you think the best way might be, and do that in a more programmatic, coding sort of way. But it's not that hard. It's not a big deal. And I wind up reusing a lot of big templates that I've written in the past for that. And then finally, the civil engineering part at the end of the course, we can start talking about specific applications like stress and strain, or maybe like how you would, predict snow drifts, or compensate for wind loads or something like that. We could compare beam classes across, category of material. And I put ellipses here because this is really kind of up to you. And once you've built the foundation in Python, like these first three parts of the course, that's really what the course is meant to teach you. I'm not a civil engineer, and so I'm not going to do a really good job like teaching you new civil engineering things. Instead, this part 4 is meant to show you how you can now start to use what you've learned in Python, that foundation, to go out and find useful tools that exist just online in general, and apply them to your civil engineering work. So we'll do a few examples of that, but it's kind of arbitrary. It's like up to you guys. What do you want to do just as part of the course at the end to explore what Python can do for you generally? All right, so our teaching philosophy here. First, it's remote. So, it'll go kind of like this, except you won't just be listening to me lecture. Instead, it'll be more interactive. So, we'll all introduce ourselves. You can have your cameras on and your microphones on when you want to talk. And, there's some lecture, there's a lot of like interaction, but it's remote. So you don't have to all be in the same room. That's, to help people who are coming from different places to all participate together. And I like that international, multinational course. I think that's cool. People like who have different cognitive, kind of more cognitive diversity, I think, tend to learn better together because they ask questions that might not have occurred to others. So, some advantages to being remote, and we'll try to keep it like nice and fun and engaging, even though you're staring at a screen rather than looking at real people in the same room as yourself. And then synchronous, so it's done at the same time, like rather than watching pre-recorded videos and then filling out, little quizzes afterward, which I think gets really kind of rote and boring. We're all going to be live together in the same virtual room. So kind of like we are right now, except I'm not doing all the talking. So you can react to content and ask questions and, piggyback each other's comments. And I think that really helps to learn. People like bring their full selves with them and are a little bit more like poised when they know that what they're checking out is live and, and happening at the same time. So very interactive, lots of group activities, surveys and games and challenges. So I'll ask for volunteers and we'll try stuff out. And, there's no such thing as failure in that case. It's just about like getting yourself into it so that you can learn it faster and it'll stick better that way. So we split you out into breakup rooms and have you work on projects together. And it's also intuitive. This is really important for us. We want our explanations for how things work to be like, well, of course, that's how it would work. So first you want to do this, right? Well, then the first step would be this. And then after that, you'd probably want to do that, right? And you think, well, maybe I should do this, but if you actually were to try it that way, you might run into this problem. And so that's why we do it this other way. So we really want to build up the logic in a nice, memorable, and intuitive way for why things work the way they work in Python. So that way that foundation we're talking about building is really solid for you. Practical. So this isn't meant to be like super academic. It's meant to be like, this gets you up to speed so you can go apply this stuff in your day-to-day workflow. If you want to learn about Python from this course because you then want to take a class later where Python's a prerequisite, this is a good course for that. But overall, like this practicality is really important. So it's not about like getting super deep into the nature of how Python under the hood is storing data. Instead, it's about like how you can use the fact that data is stored a certain way to your best advantage when you're trying to get real work done in the real world, whether that's research or business. And then cheap. So our goal is to like make this accessible to people who are in transition. So I know it's been kind of a weird year, and some people are looking for the next thing. So if you're in transition, this is meant to like be affordable, and we give you a certificate. So it's meant to be like a nice thing to put onto your resume, so you can show the world that you really understand this stuff. Then finally, there's how to follow through afterwards. So I don't like when a course will say, hey, you've taken the course, here's your certificate, get away from me and don't bother me anymore. So these are things I recommend if you do want to take a course from Inly in general. You get to keep all the materials, and so you should use them. So if you then, later on are doing some kind of work in Python as a civil engineer, you might want to refer to some of the exercises and the explanations and just copy the code from those and put them right into the workflow that you're building, in the civil engineering world. You want to internalize the why and the how by going through them again on your own. So when you're like, all right, I'm trying to get this project done, in the civil engineering world, let me go back to the assignment that I remember was kind of like that. Why was it done that way? Oh yeah, we did it that way for this reason. Cool. Now I know what I need. Let me go fix that problem and solve it in my work. Next, we want you to take advantage of our content guarantee. So stay in touch with us. If you pay for our course, what you're paying for is that you will understand the material. So that doesn't mean we just teach it to you once and then, we send you on your way. If you're like, hey, I still didn't get this thing, you just reach out to us and we'll make sure that you get it. So it's kind of like a don't leave students behind kind of concept. You can schedule sessions, you can send messages, like you have a guarantee that you need to understand what the course covered. That doesn't necessarily extend to, hey, will you do my job for me? I'm trying to apply this at work. But if you have a question about like, what's the logic or how does something work generally, then please reach out. And then next, we try to help connect you to communities of like-minded people. So obviously your classmates, but there are different kind of scales of community that you can get involved with. You can explore more from others, from the course and from other courses that we've taught in the past. These tend to be people who are like enthusiastic about Python. And you can also follow Python communities that have nothing to do with Inly, that are just out there on the internet. And I wrote for geo professionals here, but that's because I pasted this slide from another presentation. It could be for civil engineers, it could be for, in particular, say if you're like a structural engineer or a geotechnical engineer, you can find a community of people out there across the world who are working on that same kind of technical niche area that you are, and using Python for it, and start to share code and learn how they're doing things. Cool. All right. So that's actually all I have. I'll post this webinar. I'm recording it, so I'll share it on YouTube, and you'll have the link in the presentation, that the version of the presentation that I shared to everyone who joined this webinar. Thanks, everybody who did that. And if you want to follow other things, you can see how we kind of teach and what lecture material is like that covers specifics of Python directly. So you can follow this link. This is a series we did for energy and data, and this had to do with the energy industry. And then another thing that has become kind of popular that we teach aside from Python is this workflow automation. So workflow automation in particular using Excel. So a lot of people are still using Excel and they don't really want to like graduate into Python quite yet, or maybe they can't because their company won't let them, or too much of the work flow is like Excel native, and so they're kind of stuck in it. If that's the case, we teach courses on that. So I'll share the YouTube video that explains how that kind of stuff works from Inly. If you want to check out our courses, this is the website to do that. We post news periodically. Typically it's about like what else we've done in courses, or what other kind of webinars we've hosted, or panels we've sat on, or papers we've given in conferences or things like that. And all of that is on our website. If you ever want to reach out to me, just send an email to alec@inly.llc. So that's it. Thanks a bunch for joining.